Science is always moving forward, with new experiments and discoveries constantly changing our understanding of the world. In this video, we'll take a look at the top 10 most famous scientific experiments of all time. One of the most famous experiments in the history of physics, the double slit experiment, demonstrated in 1801 the wave-particle duality of light and matter. The experiment involves shining light through two parallel slits and measuring the interference pattern produced on a screen behind it. This experiment showed that light behaves as both a wave and a particle, and challenged our understanding of the classical concept of reality. Developed in 1935 by Austrian physicist Erwin Schrodinger, the thought experiment of Schrodinger's cat explores the nature of quantum superposition. The experiment involves a cat that is placed in a sealed box with a lethal device. The cat's fate is dependent on the state of a subatomic particle, which exists in a state of superposition, dead or alive, until it is observed. This experiment challenges our understanding of the relationship between the quantum and classical worlds. Conducted in 1887, the Michelson-Morley experiment aimed to measure the speed of light relative to a hypothetical ether, which was believed to pervade space and support light waves. The experiment used an interferometer to measure the speed of light in different directions. It fails to demonstrate the presence of ether, and to the surprise of the experimenters, they found that the speed of light was constant, regardless of the direction. This experiment challenged the prevailing understanding of physics and paved the way for Einstein's theory of special relativity. Conducted by American physicist Robert Millikan in 1909, the oil drop experiment determined the charge of an electron. Millikan used an apparatus that sprayed tiny oil droplets into a chamber and used an electric field to suspend the droplets in midair. By knowing the gravitational force on the droplets and the electric field applied, Millikan was able to determine the charge of the electrons. Conducted by British physicist Ernest Rutherford in 1911, the Rutherford scattering experiment explored the structure of the atom. The experiment involved firing alpha particles at a thin sheet of gold foil and measuring their deflection. Rutherford discovered that most of the alpha particles passed straight through the foil, but a very small number were deflected. This rebound indicated that the positive charge of the atom was concentrated in a small nucleus surrounded by electrons. Conducted by British physicist James Chadwick in 1932, this experiment discovered the existence of the neutron, a neutral subatomic particle, completing the atomic model of Rutherford. Chadwick used a cyclotron to fire alpha particles at a beryllium target and observed the emission of high-energy gamma rays. This led him to conclude that a neutral particle was produced in the collision, which he named the neutron. The Hubble Ultra Deep Field image, captured between 2003 and 2004, is a stunningly detailed image of a small patch of sky. The image was taken with the Hubble Space Telescope and captures the light from over 10,000 galaxies, some of which are over 10 billion light-years away. The image has provided invaluable insights into the history and structure of the universe. Conducted by physicist John Bell in the 1960s, this experiment tested the concept of quantum entanglement. The experiment involved measuring the correlation between the properties of two entangled particles, and showed that their properties were correlated, even when separated by large distances. This experiment challenged our understanding of the nature of reality and the principle of locality. Conducted by Russian physiologist Ivan Pavlov in the late 19th century, this experiment explored the process of classical conditioning. Pavlov noticed that his dogs would start to salivate when they heard the sound of a bell that was used to signal mealtime. He used this observation to study the process of classical conditioning, in which a neutral stimulus, the sound of the bell, is paired with a naturally occurring stimulus, the food, to elicit a response, salivation. This experiment laid the foundation for the study of learning and behavior. The photoelectric effect was first observed by Heinrich Hertz in the late 19th century, but it was Albert Einstein who provided a theoretical explanation for the effect in 1905. The experiment involves shining light on a metal surface and measuring the electrons that are emitted. Einstein's explanation, which was based on the idea that light is made up of particles, photons, provided the first experimental evidence for the theory of quantum mechanics. These experiments have had a profound impact on our understanding of the world and have laid the foundation for many of the technological advancements we take for granted today. From the duality of light and matter to the structure of the atom, these experiments have helped us to better understand the world around us and have shaped the course of scientific discovery.